Okay, thanks for again in the master class. Today we are going to touch upon the deep dive session into the linked list. Okay, so what is the agenda of 2 hours? Uh, so the agenda of today's in the linked list, we will just touch upon what is the why we have linked list first of all in place. What are the different basic operations that can be performed on the linked list? How you can visualize the memory and also the definition, right? And there is a different concept like fast and slow pointers, right? So that we also talk about, and there are certain problems. I am not focusing on the problem, guys. I am just focusing on the build the intuition, how you can think, and then based on that, you should be able to solve this problem. So if you look at this one, reverse a linked list, whether the linked list is a palindrome, how will you find the nth node from the end? How will you remove duplicates from a linked list? Union and intersection of a linked list and merge to linked list. These are the different questions that has a different variety of concepts. That is the reason I have chosen all these questions. Yes. After this solving, will you able to solve different problem? Obviously, yes. Because if your concept is clear, then you can apply this concept to even other problems as well, right? So that is the agenda of the today meeting. Now let's move on the actual topic. So before starting the linked list, first of all, I wanted to touch upon one story. Sorry. Imagine you are building an Instagram, or let's say you building a Facebook, right? And you have seen millions of users are uploading the posts every second, right? Let's say in if you take the example of Twitter, or if you take the example of Facebook, Instagram, whatever you can think of, right? Everybody is posting each and every second, right? Now, once this data or certain things are posting as part of comment, how are we storing that one? So think today, your system store posts in an array, right? So you are building an Instagram, and in the Instagram, right, in the Instagram application, so you all the users are doing the post, and you wanted to store all those posts inside this array, right? So far so good. Now that looks fine, but what is the problem here? So suddenly, okay, think like this one. Suddenly one user posts in the middle of the feed. For an example, let's say one comment, this is one comment, other comment, other comment, other comment, right? So these are the series of comment. Now if suppose if one user is doing the comment in between of these two comments, let's say you have a comment 1, comment 2, comment 3, comment 4, right? These are the different comments posted by the different users, and you are storing this comment, comment 1, 2, 3, 4 in your array or list, let's say array list, right? So how will you store comment 1, comment 2, comment 3, like why? And you know that, right? Array stores the data into the contiguous memory, right? I will talk about what is contiguous memory. Now someone, what happened is add comment, let's say 9 in between. So what will happen? So what will happen? So once you add this comment, so since you are adding that comment in between, all the comment, right, after that, that needs to be shifted, moved, right? Because you know, right, array stores the data into the contiguous memory. I will talk about what is contiguous memory later on, but this is the contiguous memory, means every should be side by side. Now if someone is inserting here, right, and if there are a lot of comments after that, that means all the elements needs to be shifted. Think like that. If you have a millions of user is posting, and some user is trying to post in between the comment, what will happen? It means that all the comment after that, the new comment, it needs to be shifted, right? And if it has a millions of comments, so that then definitely that will be a painful, right? So that is how we store into the array. So that means it indicates that when you are trying to insert or when you are trying to delete an element inside an array, it means you need to shift that element, right? So and while shifting those elements, right, it is, if you have millions of record, think how much time it will take to do the shifting. So generally what happened, when we are doing, we are just creating the array list, we are just creating the linked list without thinking what will be the real impact of it, right? So this is the real example where you can think of, yes, you can use array, but what is the disadvantage of array, right, in case of insertion and deletion? So I talked about contiguous memory. What do you mean by contiguous memory? Contiguous memory means, let's say, sorry, okay, let's talk about, okay,
Let's
so
talk about. Okay, so
can you mute yourself, please? Okay. All right, thank you. Thank you, guys. Okay, so contiguous memory means, let's say you have a element, let's say integer element 10, 20, 30, and 40. And if you are storing inside this array, right? So integer in Java, integer takes 4 bytes, right? So that means, let's say base address is 1000. So that means next address will be 1004, next address will be 1008, means it's a gap of 4, 4, add 4, add 4, right? So this way your array stores your data. This is the integer data. So on the base address, it is applying the data type storage, right? And then based on that, it will store this data. Let's say, for example, 10, 20, 30, 40. So that is the reason we called it array stores the data in contiguous memory location, right? Okay. Now you have heard about, you just create the array, right? But you need to think how array works, right? How array indexing works. See, I am just doing the class of linked list, but it is necessary to understand this part so that it will be clear to understand the linked list. So far with me, guys? Okay. Now, how array indexing works? So basically what happened here is, this is the base address and this is your index. Array is a index based and it starts from 0. And then size of element means integer. What is, if you wanted to store an integer value, what is the space it needed, right? It needs 4 bytes. So that is the size of element refers here. And what is the base address? So whenever you are creating an array, let's say you are doing int a is equal to new int something, whatever the different approach you took to create the array, what happened here is, while creating the array, JVM, right, and operating system manager, there is a JVM plus operating system manager that took the responsibility of creating the base address. Okay, once it decides what is the base address, and then based on that base address, it is just adding the index and the size of element. So for an example, here let's say you have value let's say the value is 10, 20, 30, and 40, and your index is 0, 1, 2, and 3, right? So that means what will happen here is, when you create this array, JVM will ask the memory manager, hey, I wanted to create this array of this size, can you give me the base address? Then it will give you the base address. Once it will give the base address, then on the base address, it will apply this formula to create the space. So for an example, let's say at the 0th index, so base address is 1000, so index is 0 and size is 4 because integer takes 4 bytes, right? So the address will be 1000. And if you wanted to store at index 1, so that means 1000 is your base address. This is not going to change because it is created, the base address is assigned when you create an array. What is changing here is this index, and it is also fixed. So right, in the memory, let's say, we'll talk about later on, but this is how it create the memory inside this array, right? Basically, this is the way this space is created by the JVM and operating system manager for the array, right? Now you can think of, that is the reason it provides O1 access. So if you wanted to access, right, if you wanted to get an element at a particular index, you will get O1 time. Why? Because there is only one operation. Who decide this one? So your JVM knows, okay, what is the base address. So if you pass, let's say if you pass array, give me 10. So what will happen? Your JVM know what is the base address of this one, and you are passing the index 10. So it will apply this formula and give you the address. And on that address, whatever the value you have stored, that will be returned. Okay, so that is the reason it provides you O1 access, because you are doing only one operation. Okay, now if you ask, give me the value stored at index 2, right? So same formula, it calculates 1000. This is your base address, right? Index is 2 and your size is 4, so it will 1000, and then it gives you the value 30. You see, it will calculate this address and then it will give you the value 30, right? So your basically your data is stored at some memory location, and that memory location is based on this index, and this value, this memory is calculated based on this index. Okay, now no, so far what we understand, so array stores contiguous memory and it is a fast access. You know why it is a fast access, right? But it is slow in case of insert and delete. In case of insert and delete, right? Now let's talk about just 1 2 minute more here. So when we create an array, the JVM asks the operating system for a contiguous block of memory, and the starting location becomes the base address of the array that we talk about. So array means contiguous memory, fast access, and insert and delete will be slow, right? So for an example, let's visualize this one. So this is your address. Think that this is your address in the memory. Okay. And let's say someone is storing this value 5, 10, 20, 30. This value just stored in the memory. Now, if somebody want to create an array of size 4, will they able to create? No, because it needs 4 contiguous free space. But here, if you did you see here, there is no contiguous free space, right? So that is the reason it will not be able to create. I'm just giving an example, right? Now when we talk about linked list do not need a base address, because nodes can live anywhere in memory. So here you see here, right? 5, 10, 20, 30. Program start using memory, some blocks get occupied, some remain free. So think like that. You have a, my screen, yeah. Think like that. Here is your RAM, and RAM has a full memory, right? All the locations of memory, right? Now, whenever JVM tries to create an array, JVM, it is the responsibility of JVM through the OS. It will check, okay, is there any free block of size 10, 20, or 30? Based on that, it will create an a space, right? Basically, it's creating an space, or you can say it occupied the space. Okay, give me a second. Why my videos? Yeah, right. So now, so in this case, you cannot create a array of size 4. You cannot create. But can you store 4 elements using linked list? Yes, because linked list doesn't need a base address concept. Linked list can store here, linked list can store here, linked list can store here, linked list. So that is the reason in case of insert and delete operation, in case of insert, okay, one more thing. Let's say for an example, this is your array, right? This is your array of size 4. And if somebody wanted to add element here, right? So that means the element stored here, right? That needs to shift here, right? So one by one they need to shift it. One by one they need to shift it. So that means it needs to calculate the address, shift it, shift it, shift it, right? If it has a millions of records, that means million of shifting will be happening, right? Then think how much time it will take. So that is the reason array is good for access by index, but it is not good for insert or delete. For an example, let's say you have value in case of delete, let's say you have 10, 30, 40 also, right? Now, if you wanted to delete 30, what will happen is if you once you delete this one, then also you need to do the shifting here. Otherwise, this space will be unnecessarily occupied. Okay, this is just I wanted to give you the concept of array. I know this is not a master class of array, but it is needed to understand why we need linked list. Okay, let's move on. So what is linked list? What is linked list, guys? A linked list is a data structure that contains sequence of nodes where each node contains a value and reference to the next node in the sequence. Okay, I already mentioned, right? Linked list and arrays both are used to store a collection of same type of data, meaning a data type can be a simple primitive integer or a complex object or a particular class. However, the structure of linked list is different as compared to arrays. We just talk about right here why we are going with for insert and delete operation, why we are going with the linked list. Why? Because linked list, you can create a linked list. For an example, let's say if you add value, let's say here you can add value, let's say 40, let's say you add 40, right? And you can add 50 here. So that, and the concept of linked list is it has two parts. We called it node, meaning it has a data part and it has a address of next element. It has an address of next element. Okay, so that means when you store 40 here, right? So there will be another pointer here that let's say points to this 50. Okay, so that is the reason linked list doesn't need a base address, or it doesn't need a contiguous memory. Okay, let me give you one more example. Um, Let me give you one more example here. Okay, think like this is your RAM. Okay, this is your RAM. Okay, and these are the different spaces. These are the different spaces into the memory. Okay, these are the different spaces in memory. Okay, now if you wanted to create an array of let's say size 5, so here there is a only one chance here. Think like that. This is the only one chance here. You can create with this one because maybe 1 2 3 4 5 array 5 length 5, so you can create this array because this is the free space, right? Now but if you wanted to create a sixth one, you cannot do that one. Now when you talk about linked list, okay, let's say it has two parts. It has two parts, let's say. So this, if you see here, this space is scattered here. Everyone, it is everywhere, it is scattered, right? I mentioned two parts. One is it has the value of 10, right? And it also contains the address of the next element. So think like that, the value is 30 here, and uh, here the this is the next address. So here 30, right? Let's say space, let's say a space, called it a space 1, and this is called a space 2. Okay, now linked list is a node, so you can think this is your node and it has two parts. One is the data part, the actual data. So let's say this 10 is your actual data. And the other part contains the address of the next node. So let's say you called it a space 2. Okay. So if you know this node has the data and it also contains the space 2, so through this space 2 I can reach it here, right? Think like postman, right? So postman knows the address, right? If he knows the address, then only he can reach to the um reach to the customer, right? They can deliver the post. So in the similar way, these nodes are basically, it has two parts. Okay. So this is connected with this one. This is connected with this one. This is connected with this one. And let's say in somewhere it is here, and this can be connected to this one. The reason is, for each node contains the address of the next node. So let's say at P1, right? And this is, let's say, P1. This is P2. This is P3. And this is P4. Okay. So since it contains the address of this next node, so from here we can reach to this node P2, right? Since this P2 contains the address of P3, so from here we can reach here. So similar way we can reach here. So that is the reason I said linked list is nothing but nodes that are connected with each other through the address. Okay, guys. So, yeah. Okay, fine. Now, what are the different applications where linked list is being used? Okay, hash map, file system, adjacency list. Okay, if someone doesn't understand, raise your hand. I can answer those questions. Make it interactive. Okay, all right.
I'll just call out one thing here,
Yeah,
that this what you mentioned about the memory,
yeah,
right? Have to because arrays are based on the contiguous memory.
yeah,
That is the foundation
yeah.
why we always need to provide the size of arrays while creating the arrays.
That's
Because if we
correct.
do not provide the size,
Yeah,
we'll not get to know how much space needs to be allocated based on the data type.
yeah.
So that is important. Means that if we remember that thing, we'll always remember that the size of arrays are given at the time of declaration or instantiation,
Yeah,
fundamentally because so that it can allocate that much contiguous memory at the
that is
time of.
correct. That is
Yeah.
correct. That is correct. Right. Yes, Durgas.
We can go ahead. Thanks.
Yeah. Okay. So guys, now what are the different applications that uses linked list? So if you go there, I'm not discussing that too much. There's a hash map, file system, there's a adjacency list. These all are the different applications or data structure where this linked list concept is being used. Okay. Now what okay, so this is the very important concept, linked list structure. So it is formed by nodes that are linked together like a chain. Each node holds data along with a pointer to the next node in the list. So for an example, you have a data and here you have a pointer, you have a data and here you have a pointer, you have a data and here you have a pointer, right? So all are connected with each other, right? And the first node, we called it the head node. The first node, what we called it the head node, because this is the head node. And last node your last node, right? So if it doesn't point to any object, any other node, that means it will point to the null. And also you can see the last node, we called it tail. Okay, these are the different terminology used in linked list. So your head node will be the first node and your last node will be the tail node. And last node, it doesn't point to anything, any node. So that means it will be null. There is an edge case. We'll talk about cycle later on. But at this point of time, think that your last node is pointing to null. Okay. Now let's move on. So you can visualize a linked list as a sequence of nodes connected by arrows that point to the next node in the sequence. Okay. So for an example, let me draw this one. Okay. What is the head node, guys, here? Your head node is this node. Let's call it list node 1. Name it list node 1. Now, okay, let me draw one more diagram here. So let's say, okay, let's say 1, 2, 3, 4. Okay, and it has the address also. This is the node we represent here, right? This is the node. Now, what we called here, first node is the head node. Okay, and first node is called the head node. Let's say this pointer is nothing but a next. This pointer is nothing but a next. Okay, so head, this is next. So if I wanted to reach 3, how will I reach? Ritik, if I will do head dot next, what is the value I will get?
Head dot next. Then we will get 2.
2, right? Why, guys? Because head node is the first node and saying what is the next node of head. The next node of head is 2, right? Now, if I wanted to reach 4, Kshitiz, what should I do here? Okay,
Then we continue with head dot next dot next.
so head dot next, you will reach here. Head dot next, you will reach here. Head dot next, you will reach here. Did you get how you can reach here? So what is the what is the fundamental thing here? So if you know the head node, you can reach any node into the linked list, in that linked list. Are you guys with me? Okay.
Yes.
Okay. Now linked list implementation. So how will you implement the linked list? See, every language, let's say Java, C++, every language has their own implementation of linked list. But if somebody asks you, how will you implement your own linked list? How will you implement that? How will you implement that? In Java, so basically 2 classes needed for the implementation. One is the node and another is the linked list. Okay, so how will you structure the node? So node has 2 parts. This is generic parts we'll talk about later on. Just think that this is the node and it has a data and it has a next node. And what will be the return type of next node? Node, because next node represents the next node, right? In the linked list, this is your next node, right? This is your next node, right? When we talk about 2, what is this 2? 2 is the next node of 1. What is 3? 3 is the next node of 2. What is 4? 4 is the next node of 3. Okay, so when you defining your node class, it has 2 parts, data and next node. Data, it could be anything in string, object. right? And next node is basically your pointer that points to the next node. So now what is T here? In Java, there is a generics. Okay. The reason I called it out here is maybe it is not needed here, but just I'm calling out here. See, when you create a link list, it doesn't necessary that you store only the integer data type, right? You can store string also, you can store object also, correct? So that is the reason we make it generic, so that whenever anybody wants to create a string or let's say integer, they can utilize your class. If you will make it specific to your integer or string, then what will happen for each data type, right? You need to create the different implementation. So that is the wrong design. So that is the reason you should always go with the generics mean, because if you are implement, say, think like that. Now the Java class already has a linked list class implementation, right? Now when you use that linked list, you can create an integer array, sorry, integer data type, or you can create an string type. Any data type it can suffice, correct? So that means you should create a structure in such a way that it can accept any data type, and the way to achieve that is generic. I will not talk about the generic in this class, we'll talk about later on. Okay, again I will share the notes, but what once you represent T, right? What does T represent? Can we use another letter instead of T? These are the different questions that is not part of this. I just mention here so that once I will share the note, so through that you can understand, and also how T behaves, right? When exactly it is changing, all those concepts are written here. I'm not going to cover this as part of this master class. Okay, now, okay, now let's understand the class. So we define a linked list class, right? So what I mentioned, when you define a linked list structure, there are two classes we need to must care about. One is the node class. This is very important. Why? Because this is the node that represents the linked list node, and it has two parts, that is data and the next node. Okay, and the another aspect here is head node. You must need to know the head node, we'll call later on, right? And then other part is the size. So what is the size? Meaning when each time when you add an element inside the linked list, you are going to increase the size or what length, correct? So that is the size represents here. And this is the constructor. So initially when there is nothing, let's say when you created a linked list, right? So that means there's no linked list, right? There is no node. So at this point of time your head node will be null and size will be 0. We will implement this one. Okay, so basically your singly linked list, again there is a two type of linked list, singly linked list and doubly linked list, that we will talk about later on. But at this point of just focus on the singly linked list. Okay, singly linked list is made of nodes that are linked together like a chain. We already discussed, right? One node is connected to another node is connected to another node, first node, second node, third node, right? Now to access this chain, we need a pointer that keeps track of the first element of the list. So you must need to know the head node. If you don't know the head node, you don't have clue where that resides into the memory, right? Why? Because node, whenever you create a linked list, it doesn't store the data into the contiguous memory as compared to array. Because in array, these are the contiguous memory. If you know the base address and you know the data type, you can determine what will be the next address. But here you don't have any clue. So the only way to reach any node in the linked list is the head node. Why? So because if you know the head node, so that means that head node contains the address of the next node, and that next node contains the address of the next node. So that is the reason you can reach at any element in the linked list through the head node. Yeah, see, I mentioned here, if we know about the first element, we can traverse the rest of the list without worrying about their storage location. We don't care where it is storage. What we care here is the head node. If you know the head node, so that means through head node, I can reach to any node. Okay, this is very important concept. Let's understand this one. Head node. So here head node variable of type. What is the type of this head node? If you look at this head node, right? What is the type of this head node? Node. Okay. So head node variable of type node. It points to the start of the list. That is head of the list, or you can say first element of the list. So if you wanted to understand or know what is the first element of the linked list, you need to take head node as the first node, right? In the constructor, if you, I was talking about this constructor, if you talk about this constructor, in the constructor head node is null and size is 0. So in the constructor, we have initialized the head node so that it becomes functional. If the head node points to null, it means that list is empty. Correct, guys? So what we are saying here is this is your head node. This is your head node, right? If it is a head node, so that means it is pointing to something. Now, if your head node is pointing to null, so what does it means? It means that there is no element in the linked list. No element. Okay. Okay. This is also, again, I was just talking about this generic here. Will not talk about this one. You can read it later on. This is also about the generic, how you can, it's more on the generic. It is in the arrays concept. So we'll not talk about this one. Okay. Now let's talk about, we understand linked list, right? Now we will talk about what are the basic operations you can perform in the linked list. So what are the different basic operations? So insert at end, right? You pass some data and you want to insert at end, right? And insert at tail. It is same thing whether you call it insert at end or whether you call it insert at tail. Tail means last element of the linked list, or end is also referred to the last element of the linked list. So whether you want to, let's say you want to store some data at the end of the linked list, or insert at head, if you want to add certain element as a head element. Okay, so insert is the basic operations. Delete is also the basic operations. When you say delete, there are different combinations where you are going to delete the data, certain data into the linked list, or you want to delete at head, delete at end. See, if you look at this one, delete at head, no parameters. You see, I don't pass any parameter. Why? Delete at head means delete the head element, head node. Delete at end means delete the last element of the node. Okay, and here delete. Delete means, let's say linked list has value 10, 20, 30, 40, and you wanted to delete 40. So you will pass 40. Right, so there are different flavors of delete, and similarly there are different flavors of insert. And obviously search, let's say 10, 20, 30, 40 the data is stored into the linked list, and you wanted to search any element inside the linked list, then you can perform search operation. Is empty, this is a helper method, whether your linked list is empty or not. Correct. And then find the length. What is the length of the linked list? All these are the basic operations. First we will do, understand, build the intuition. Then after that we will slowly solve the other bigger problems. Okay. Now we will start with the basic function is empty. Helper function, it will be used in other basic operation. We will see how it can be used. Okay. Now, even this is the very important concept, guys. A linked list will be empty only when head points to null. Are you guys with me? A linked list will be
Yes.
empty only when head points to null. So that what is head? Head is the first element of the linked list. And if it represents null, that means it doesn't point to any node. Right? So that is where you can say linked list is empty. Now, even when a linked list is empty, the head node must always exist. This is the basic concept. Keep in mind, even when a linked list is empty, let's say your linked list is empty, the head node must always exist, right? Head node must always exist. And here, in case of linked list, when it is empty, it is pointing to null. It is exist, but it points to null, and that indicates that there is no element in the linked list because it points to null, means no node. Okay. Now we are going to, so I've just taken the same example here. So this is your basic fundamental structure of the linked list. This is the singly linked list class, or whatever the name you called it, and it has a node class, and node has a data and next node, right? And then you have a head node that represents the first element of the linked list and size. So, and initially this is the constructor, right? So that means very first time your head node will be null because your list is empty. So since your list is empty, so that means your size will also be 0 because there is no element into the linked list. Now we are going to implement is empty, the basic operation, very basic. So what should be the condition? Your head node. If your head node is null, that means it is empty, otherwise it is not empty. Are you guys with me? If your head node is null, so that means there is no data, right? So when your head node is null, that means it is empty. Return true, otherwise it will return false. Okay, see the basic. If you understand the basic, you can easily write one operation. Okay guys, now let's move on. Now, okay, this is okay, find length. Find length. For an example, let's say this is your linked list. Okay, all these are connected. All these are connected. Okay, and this is, let's say this is in your RAM. This is your RAM, and it can connect to like this way also. It doesn't matter actually. Okay, connect to this one. Okay, what is the length here, guys? What is the length? 1, 2, 3, 4, 5, 6. Okay, what is the length? 1, 2, 3, 4, 5, 6. How will you know that? What I did, I'm just counting 1, 2, 3, 4, 5, 6. From where you start counting? From where you start counting?
And
First node, right?
uh,
The head node. Why?
yeah,
Because you only know the head node. You don't
where the
know,
head.
yeah, we don't know about the other element. So this is your first node. So look, what are we doing? We are trying to find the length and we are counting. Where we are counting? We are not counting from the reverse. We are counting from here. 1, 2, 3, 4, 5, 6. That means we are counting from the head node. That means we are just going node by node. That means we are traversing. Traversing what? we are going to the entire linked list to find the length. Where I will stop? Where I will stop? The node when it points to null. So
Null.
that
Yeah.
will be the last node. Where I will stop, that is the last node. So that is what exactly, see, build the intuition and just do the code. So find the length. How will you find the length? So you have given a head node, first node. Okay. Now what you will do? You will take a length has 0, right? And node, your current. Okay, guys, one important point here. So you have given a head node. Always remember, we are always taking a temporary node or temporary variable. Okay, and we are operating on the temporary variable. You know why? The reason is why? I will tell later on. I will tell later on. But for a moment, just think that we just assign a head node to the current node. Okay, so that means your current and head node is pointing to the same. That means here your current is nothing but your head node, right? Now what are we checking, guys? Current is not equal to null. When current is not equal to null, so that means length we will increase. Once length will increase, then we need to move to where? Next node. Next node. How will I reach to the next node? Then you,
Current dot next,
yeah,
right?
yeah, your current will be current dot next. At this point of time, this is your current. At this point of time, this is your current. But once you move here, so what is the address, guys? Current dot next. Look at this. You remember? That is the reason I described this part earlier. You see here, how will I reach it? This is your head node. Once I wanted to reach here, head dot next. Wanted to reach here, head dot next, next. Okay. Now if you wanted to reach here, head dot next. Okay. Now see, what are we doing here? I will make another diagram here. So your current will be current dot next and then return length. So what will happen? Let me just clear it out. And then let me draw this one. Okay, let me draw this one. I know there are certain guys, maybe they will have little confusion, but let me just draw this one. Okay, value is, let's say, 1, 2, 3, 4. Okay. Now, when I said current is not equal to, okay, let me go line by line here, guys. When you say current is equal to head, what is the head here? This is your head, represents this one. Now, current is equal to head. That means current will also point to this one, right, guys? When this line will execute, your current will also point, because you are saying that head you are assigning to current. That means current will also pointing to this one. Okay. Now we are operating on current. What we are saying, current is equal to null. Current means node. I am saying, talking about node. This points to this one. Is it null? No, it is not null. So it will come inside this loop. It will increase the length. And then what it says? Current dot next. Look at this line. Current dot next. What is current dot next, guys? This two. That means this is your current dot next. And where you are assigning current, that means this current will move from here to here. Your current will move from here to here. Okay, then again it will go here and it will check, is this current is not equal to null? No, it is pointing to 3, so it is not null. So it will again come here, increase the size. Okay, and then it will say, now my new current will be current connects this one. So this is your new current. Okay, Same way, then it will go here. Oh no, it is not equal to null. Then it will increase the length, and then it will again go to the current dot next. This is the current now. Now current dot next will be this one. Now this is my current. Now it will go here, current dot null. See, this is pointing to null. There is no node connected here, right? That means it is null. So when it is null, it will execute the loop. Are you guys with me? So this is the way, this is the how you can find the length. Okay, one important thing here, you need to know the head node. If you don't know the head node, you cannot traverse. This is the key concept, guys. Always remember. Okay, now I was saying one more thing. Let me just clear it out. I wanted to build one more concept here, then we'll move to the next set of basic operations. Okay, so let's say this is your RAM. Okay, now let me move here. Okay, now let me draw here. No worries. Let me just draw here itself. Let me take only 3 element here. Okay, value is 1, 2, 3. Some value is there, and this is the pointing to this one. This is pointing to this one. Okay, now why we have, see, generally people don't understand why we are taking this current. Why can't we do just head? See, the problem here is, let's say if you don't do the current, let's say if you don't do this line, okay, instead of current, you just do head. Head is not equal to null head. So you know what will happen? Let's say if you operate on head, now head is pointing to this one. Now after executing this line, now your head will be pointing to this one. Now head will reach here, right? Now in later part, if you know where is the head, see, now head is pointing 3, but you lose the information about the actual head node. Are you guys with me? You lose the information about the head. Since your head node is reaching here, you lose the information about the head node, right? Now later if you need the head node, you don't have clue where to start. So that is the reason we have only one source of truth, only one information, head node, and I do not want to lose that information. That is the reason we assign the head node in a temporary variable, and then we are operating on the temporary variable so that our head node will be intact. Are you guys with me?
Yes.
Okay, let's move on. Okay, now we will do some basic operations here. Insert operation, right? So I was just talking about insert at head, insert at end, insert after an element. Let's first visualize this one, insert at head. What does it means? Insert at head means insert a new element as the first element of the list, right? So inserting at head means basically you are inserting a new element, and that new element will be your new head if already some head exists. Okay, so since head always points to the first element of the list, insertion at head means we are inserting the first element in the list. Okay, now let's visualize this, guys. So initially your head is pointing to null. Okay, that means linked list is empty. Now you insert 1, you are going to insert 1. So that means now your head will point to this new node 1. Okay, and then it points to null. Now earlier head was pointing to null, now your head is pointing to 1. So that is the meaning of inserting 1 at head position. Okay, now 1 become the next element of head. 1 become the next element of head. Now take the another example. Here let's say you have a head and 1. So let's say this is already there. You already inserted 1. Now you are trying to insert 2. Where you are trying to insert 2? At head position. So what does it means? It means that this 2 will be the new head. Okay, and whatever the previous element was the head node, now it will be the next element of this head node. Are you guys with me? So 2 becomes the next element of head and 1 becomes the next element of 2. Repeating one more time. So head is pointing to null. You are inserting 1. So that means 1 will be the first element. So it will insert at the head position. What does it mean? It means that head is pointing to 1. Okay. Now, after you insert head is equal to 1, now what you did it, you are trying to insert 2 again at the head position. So that means you are saying that my new head will be the 2, not 1. So that means, so what will happen? Now your head will be pointing to 2, right? Because this is your new head, and then 1 will be pointing by this head node. We'll see in action in the next class, next chapter. So you got the intuition, right? So inserting element at head means you are going to add the first element of the linked list. Now, how will you implement that one? How will you implement that one? So implementation, insertion at head. Be careful, guys. Understand this part. So what we are going, insert at head, some value is passing. For example, here you are passing 1, here you are passing 2, right? So here you are passing, let's say some value is passing. Okay, 10, 20, any data you can pass, right? Now, let's say you are passing, some value, let's say 30 or something, right? And that needs to be added as a head node. Okay, how will you do that one? So the very first step here is, you will create a new node. So this is not a node. Remember, this is not a node. This is some data. Some data you are going to insert. What we are trying to insert, inserting 1. 1 is your data, 2 is your data, integer data here. So here you are going to add some data. So to add this data, we need to create a node with this data, right? So that means create a new node and assign a value to it. Okay, so how will you create a node? So you already define a node class in the implementation, right? We already define a node class here, right? So what we are going to do here is we are creating a new node, guys. So new node, we are creating a new node, right? And then new node ka data dot data, that data we are assigning. So here in this step, what we did, we just create a data here. We create a node. First we create a node, right? And then we assign this data 30. Where this node is located? In memory, RAM. Okay, RAM. Okay, now linking head to the new node's next node. Okay. What will be the new node dot next node, guys? What will be the new node? This is your new node, right? This is your new node. So new node dot next node will be the head node. Right? So whatever the node you have created, right? Whatever the node you have created, next node of this node will be the head node. Okay, and then why are we doing this one? We'll talk about later on. Okay, and then your head node will be the new node. See, guys, what is the intention? The intention here is this new node will be inserted at head node. So your head node is nothing but it will point to the new node. It will point to the new node. And then you will increase the size. So what are we doing here? Linking head to the new node's next node. I know some people have confusion why we are putting head node here. Why we are putting head node here. Okay, this will be clear. Okay, but at this point of time, you got idea, right? When you are trying to insert at head, very first thing what we are going to do here is we are creating a new node, right, with this data. That means you created a node, but it is in memory and it is not associated with any linked list. To associate this one, what you need to do to associate this new node, right? Association means it should be referenced, right? So who will refer this one, guys? Where are you inserting? Inserting at head. That means your head node will be pointing to this new node. Your head node is pointing to this new node. That is what exactly we are trying to do. Okay. So the goal of insertion at head means insert a new element at the beginning of the list and make it the first node. Make it the first node. We'll talk about this one later on. Hold for us some time. It will more clearer in the next example. Let's visualize this one. Let's visualize this one, guys. I was talking about this one, right? Let's visualize this one. Let's say assume the list already looks like this one. Let's say you have a list with 10, 20, 30, and this is pointing to null. And this is your head node. 10 is your head node. So what are we trying to do here is insert 5 at head. Insert 5 at head. So what will happen here? So that means 5 will be added here, right? And it will point here. Are you guys with me? This is how it looks, how it will look, right? After inserting 5. Okay. Now, what is the step 1? You created a new node and you assign the data to the new node. Okay. Now, in memory, how it looks like? How it looks like in memory? 5, it is pointing to null, and this is your new node. That is how it looks like in memory, right, guys? See, this node is not connected to the list 8. If we stop here, it would be lost. Once you create and if you don't assign, there is no meaning. It will be there into the linked list, but it will be as it is. Right? Okay. Now, to make this new node as the head node, so what are we going to do? Here I mentioned, right? This line, right? New node dot next node is equal to head node. So new node, what is new? Think in the memory perspective, guys. This is very important. The new node should be point to whatever node was previously at front or connect to the new node to the existing node. So what I said here is your new node, if it will happen, your new node will point like this one, and this will be the new node, right? So 10, 20, 30 null, 10, 20, 30 null, 10, 20, 30 null. This is your original list. Guys, are you with me? And this is your head node. This is your head node, right? Nothing is lost, the exist. Okay, right? And what is your new node? This 5. What is the new node here, guys? Guys, are you with me? Okay, what is the new node? 5. This is the new node, right? So it should assign here. Okay, nothing is lost. The existing list is intact. You got why we have this head node here. The new node dot next node is equal to why we had done the head node. If you don't do this line, new node dot next node is equal to head node. If you don't do this line, so then this entire thing will be lost. Are you guys with me?
Yes.
Asutosh, did you get it?
Yes, yes, yeah.
Okay. So you understand the importance of this one, right? New node dot next node is equal to head node. Before, see what I said, guys. You are assigning new node. Think you are assigning new node. Okay. You are assigning new node to the head node. Okay. If you don't execute this line, so what will happen? If you don't write this line, you know what will happen? It will become the head node. That is for sure. If you execute this line, it is for sure this will be the head node. But what about this entire set of data? It will be lost, right? So that is the reason what we are saying कि new node है जो है, this new node's next node will be the head node. Means that means whatever the head node at this point of time is there, it will assign to the new node next node. That means this picture is clear. Now this new node will be now assigned to the head node. So that means earlier head node was pointing here. Now head node is pointing here, and it will have all the elements intact. Okay, guys. Okay. Okay. I am emphasizing in this one because a lot of people don't understand this one, why exactly we are doing. So why do we do this before changing head node? If you change head node first, you lose the rest of the list. Okay. If let's say if you write like this one, head node is equal to new node, and then after that you will write new node dot next is equal to head node, your old list will be lost. That is the wrong order. Okay. Let's move on. Now insert at end. So insert at end means insert a new element as the last element of the list. Guys, what is the operations we are trying to do? Insert at head. So insert a new element as the last element of the list. So here your head is pointing to null, right? And when you are trying to insert one, so that means your one will be the head node. One becomes the next element of head node, right? Now, if let's say head 1 and you are trying to insert 2, where you are going to insert? At the end. So here 2 will be at the end. Remember this thing. Okay, let me go here. Where is the example? Okay. If you carefully observed, we are inserting 1, inserting 2. So whatever we are inserting, it is going as a head node, right? Because you are inserting at head. You look 2 and then 1. 2 is pointing to 1. Okay. But in this case, it is very easy. Whatever the element you are going to add, that will be added at the end. Now 2 becomes the next element of the, and 2 will be the null. So whatever the new element you are going to add, that element or node will be the next element of the previous node, and the new element points to the null value. How will you know the linked list comes to an end? When your linked list points to null. So insert at end. So insert at end. Okay. Now we are trying to insert at end. So if the list is empty, guys, there are a couple of use cases here, right? What if list itself is empty and you are going to insert at end? Don't you think if list is empty, so that means it is as good as inserting at head?
Yes.
See, where we are going to add insert at end, right? So insert at end means, let's say if linked list itself is empty. If it is empty, that means it is as good as inserting at head, right? So that already we discussed here, insert at head. Okay, now if the list is not empty, give me a second. If the list is not empty, then how are you going to do?
Then we'll go till the last node and then insert.
Right.
We first
So-
create the new node,
Yeah.
then go to the last, add this new node's reference to the last node. Then we are done, right?
Right, yes. So think the very first step is always remember that we need to create a new node. Okay, because you just pass this data, right? And to make the node complete, you need a data and reference, right? So with this data, what you do, you first create a new node and then you assign the data to the new node. So once you do it, so that means in memory how it will look, your new node will be pointing to, let's say if you are inserting 40, so it will be like this one, 40 null. Correct. And whatever the new node you have created, right? The next node of the new node will be null. Why? Because you are inserting at end, and inserting at end means the element you are, or the node you are going to add will be the last element of the node, right? So since it is the last element of the node, so that means it will be null. So that is the reason it is null. Okay. Now, what happened, guys? At this point of time, you just, let's say you are adding 40. So this element is created, right? Like this one, 40, and this is null. But this is in RAM. We need to connect it. Connect it to what? The original list, right? So let's say if this is the original list, if this is the original list, so that means it needs to add here, right? It needs to add here at the end. So at this is your initial list. So that means this is your what? This is your this is how will you know this is the last node? If the last node points to null. So what exactly that is what we're trying to do here. We have just taken a temporary node, last node, and we say, okay, this is your head node. So that means this is your head node, and this last will also point to this head node. Okay, now we'll traverse till end, right? So what we are doing, last dot next node is not equal to null. So then if it is not null, see, our main intention is to reach at the end. To reach at the end. To reach at the end, we are checking last dot next is equal not equal to null, right? Then we move to the next node of last. So let's say this is your last node. Is this a last node? No, because it points to some node. Okay, let's move forward. Is this the last node? No, because it points to another node. Let's move forward. Is this the last node? Oh yes, because it points to the because it points to null. So that is what exactly we are trying to find. When last dot next node is not equal to null, we are just keep moving last dot next node, right? Now, once it reaches here at the end, so that means last dot next node. This last, I reach here. This is my last node. Now, last dot next node will point to this one. So, last dot next node will be point to which node? This node. What is this node? This is a new node. So, it will point to the new node and you increase the size. So, make the new node as the last element of the last node. Next element of the last node. Are you guys with me? Okay, now let me, okay, did I do this one? Okay. If you visualize this one, this is the visualization. Okay. 10, 20, and 30. Okay, this is the new node 40. New node. And it is pointing to null, and it is pointing to null. This is the head node, and you also called it the last node. You are keep moving, keep moving, keep moving till you find null. So once you reach here, you will stop. You will find the last node. Now at this point of time, your last node is pointing to null. Now it should point to this new node. That is what exactly we do. Last node, last का जो next node है, last dot next node, it points to the new node. Okay, and then insert after. Insert after. So insert a new node after given node. So it is very easy. Let's say visualize this one. So you have a head node here, 1, 2, 3, 4, 1, 2, 3, 4, it is pointing null. And insert 10 after 3. Means after 3, you need to add what? 10. So your current starts at head and check for the node value 3. Why node value 3? Because you need to insert value 10 after the value 3. So what we are checking? Current starts at head node. So this is your current head node and check for, oh, this value is equal to 3? No. Let's move on. Move on. Oh, this value is equal to 3? Not found. So current moves to 3. Next value. Okay. This now current reaches here. Is it equal to 3? Oh, yes, it is equal to 3. So that means what is the criteria? Insert a new node after. Hello, guys. Am I audible? Guys, am I audible? Sorry, guys, I have some network disturbance. Okay, let me share the screen again.
Zoom is tired, but Bipin is not tired.
Okay, hold on a second. Okay, perfect. So are you guys able to see my screen now?
Yes.
Okay, perfect. Okay. Yeah, so okay. Insert after, right? So we are here, right? Insert after. So insert a new node after given node. So what we are, yeah, so we reach, okay, till which point you have seen that one? Okay, let me reiterate, no worries. So the criteria is we need to insert values 10 after 3, right? So your current starts at head and check for the node value through 3, right? We'll check. So we'll start from here. Okay, whether 3 is equal to this value. No, 1 is not equal to 3. So it will not found. So your current moves to this one. So it moves here, right? And then current moves here. So once current moves here, so what we are checking, whether the current value 3 is equal to 3 or not. Oh, yes, it is 3. That means after this node, we need to create a new node and assign this node. So what will happen? So you create a new node which value 10, and this, since at this point of time the node 3 is pointing to 4, now it will not pointing to 4. So now it will start pointing to 10, and your 10 will start pointing to 4. This is how it should be. Okay, this is how it should be. So what is the steps? First, you create a new node with that value, right? And iterate the linked list and check for that value, whether equal or not. If it is not equal, just move forward, move forward, move forward. Once you find that, okay, you found that this is the element, after that I need to add one element, the value is 10, right? You create a new node with this value 10, already you have created. Now you need to assign that new node to the next node of 3, right? And also the new nodes next will be 4. We'll see in action how it will be. Okay, so insert after. So I always mention, right, create a new node first and then assign the data, right? And then you take a current node. As we always say, why we are doing this one, we are not operating directly on head node, we need to operate on the current node. Now traverse the list until the node having data equal to previous or not. So what we are checking, current node is not equal to null, and current node data dot equals previous. If it is not equal, then we just move next. That is what we did, right? If it is not equal, just moving. So if it is not equal, we are just moving node by node. Okay. The point where it condition false means if current node of previous node is the value is matching. So that means you got the current node. Where what does it means the current node? Means after that you need to add the new node. So again you are checking if current node is not null in case previous is not found, right? So now new node, next node, guys, new node, whatever the new node you have created, so new node, next node will be what? 4. How will you get 4? The current's next address is 4, right? So that means current node, next node means current node dot next node means this node. It will be assigned to what? New node dot next node. That is what exactly we are trying to do. Current node dot next node, we are assigning to the new node next node. So far with me, this part is done. This is connected. Now we need to connect this to this one. To connect to this one, now current node, next node. At this point of time, the current node is pointing to 4. Now current dot next node will pointing to the new node. So current node dot next node will be pointing to the new node. That is what we try to do here. If you understand the concept of pointer, it will be very easy to visualize this one. Okay, then after that we have a delete operation and other operation, right? Now let me just take a little pause here and we'll do one thing. Give me a second. Let me stop share and let me share screens and yeah, let me share. Are you able to see my IntelliJ?
Yes.
Yes.
Okay, perfect. So just do certain things here. Whatever we have just discussed, let's talk about this one. So we have a list node class, right? So this is the class linked list operations. You can name it anything. The important part here is that this class, inner class, this list node, right? So this list node has value. Okay, let me just add, it's not needed here. Okay, and then you have a next node. So you see here list node, next node. So next node is nothing but a pointer to the next node, right? And this is just initialization. The part I'm trying to do here is this is the structure we talk about. So we have a, you can name it singly linked list or anything. Okay, and then what we have done list node. We define a variable head node, and also we define a size, and then we define, once your head node is null, that means there is no element, and size is 0 means there is no, it also indicates that there is the linked list is empty. Okay, and how we implemented that one, let me just do this one. Okay, how we have implemented this? Boolean is empty. We checking, right? If head is equal to null, then return true, otherwise it will return false. Now, insert at head. What we are doing, guys, here, list node, new node. We just created a new node, okay, and then new node's next node is the head node. The part I am trying to make you understand here is, okay, let me do one thing just to visualize these things. You can do it later on, but I wanted to show you one thing. So that, okay. Let me start in debug mode. Okay, where is linked list operations? Okay, let me just remove this guy. Perfect. Why we have, okay. Okay, this is my current file. Okay. Guys, okay. So let me put the breakpoint, guys, here. Guys, you see here, what is the head node? Null. What is the value we are creating? See, what happened here is we are trying to insert at head, and the value is what is the value we pass? 50. So look at this one. Initially head node is null because there is the linked list is empty, right? Now when you go to the head node, here head node is pointing to null. Now what we are doing here, guys, create a new node and assign the value. So new node is equal to new list node. So if you look at this one, now look at this new node. What is the new node? You see here, value is 50. What is the next node it points? It points to the null value. Forget about this is the since you have defined the inner class, but the important point here is new node, the value is 50 and next node is null. Okay, so this is, and you see here linked list operation dot list. Look at this one, list node at the rate of 701. Okay, though this is not a memory, actual memory, but you can think like this one. This is the address in terms of, you can say, memory address. That is not actual. This is the IntelliJ internal development, right? There they represent this one, but you can, through the identity hash, you can find what is the address. But it makes clear that this new node has some address. Think like that at the rate of 701, and the value is 50, and next node is null, right? And look at this one head node. Head node is null. Okay. So you see here, observe this value, head node is null. I'm just highlighting here. Okay. Now when you go to the next line, you see what is the new node, guys? New node is value is 50. Still it is not. Once line number 35 will execute, so your new node, right? Your head node will point to the new node. What does it means? Your head node will have the value 50 and this one. Let's execute this. You see this head node. You see this head node. What are we doing here? Well, your head node is pointing to value 50. Your next node is, did you observe one thing, guys? Here at the rate of 701, at the rate of 701. You see here, I'm saying here at the rate of 701 and here at the 701. What it does? See, this is the memory. See, it doesn't occupy the memory. What it does, it refers that memory in the RAM. It refers that memory. Okay, so you created a new node, value is 50, next node. Once you assign the head node is equal to new node, okay, it will What it will do? Insert at head means your new element becomes the head node. You see here, value is 50, next node, and your size will be 1. Okay, now let me pass this one. Let me do one more thing. Let me do couple of things. Generally, what happened is you just create a linked list. Okay, done. Iterate, done. But you should understand what exactly this means. Okay, now let me put the breakpoint here. Okay, see, very first time, head node
Screen is not visible. Properly.
screen is not visible.
It is, it is.
Okay, I think
Screen.
maybe your rejoin, maybe your internet issue. Okay, let's move on, guys. Okay, so again we are running, right? So again the same thing, but the part I'm trying to make you understand is let it pass. Okay, now look at this, guys. Where, okay, we see where, what is this, guys? Head node value 50, but where is that part? Okay, now let me stop. What I'm trying to make you understand here is, let me go there. Okay, you created a new node. Okay, assign that one. Till this point, last time also we discussed, right? So you have created a new node. The value is 50. Next node is null, and your head node is value is 50, and next node is null. Okay. Now, and size will be 1. Okay, that's fine. Now, once execute. Okay, let's execute completely. Now observe this one. Where is your new node, man? Where is your new node? It gone. Right. That was the temporary node you created and you assigned the head node. So that is the reason the value 50 and next node, right? You see here, next node is equal to none. Now head node is, you inserted basically value 50 at head node. Okay. Now observe now what we are doing. The next step is we are trying to add 40. So where it will go 40? So here value should be 40 and next node will be the 51. This will be the next node. Observe this 701. Observe this line 701. We'll talk about. Okay. Again, you created a new node. See, new node again you created. What is the value? Now this time value is 40. And next node, what we did, guys? We created a new node. And the new node, next node is head node. New nodes, next node is new node, next node is head node. Once you execute the line 34, so that is the reason you say your new node is value is 40 and the next node of new node is 50. Look at this 701. 701. See, new node is 702, but what was the previous node, head node? 701. And that 701 is a what? 701. This is the earlier, this was earlier 701 was the head node.
Head
Now,
node.
yeah, earlier 701 was the head node. Now, since you are adding 40, so now 40 becomes the 40
Head node.
becomes the new node, and the previous node will not be the head node, it will be the next node of the new node. So that is what it says, new node. Okay, and then increase the size. Now once you do this one, okay, now observe this one. Your what is the head node, guys? 702. Now next node 701. You see, so see this one, how this is connected. 40, next node, this is the next node. 701 is the address, that is 50, and then next node is null. But where is your current, where is your new node? Okay, let me just do one thing. Let me put the breakpoint here also. But you see here, right? But you see here, right? Size is also 2, but you don't see the new node. So new node is just you created a temporary node. Once you assign, it will gone. Now you created a new node, 30, and that 30 basically you wanted to insert at where, guys? This will be the head node. So this is your current. What is the head node? 702. 70 points to 701. Right? Now once you create the 30, what is this? Look at this one. Okay, let me just create a new node. Head node. See, you have only two node here. New node 703. Value is 30. And at this point of time, next node is null. Line number 34 is not executed. So new node value, you just created a new node. The value is 30. Here next node is null and the address is 703. It is just in the memory, but it is not being connected. Okay. Now look at your, observe your head node. So your head node is 702 and 702's next node is 701, right? Once you execute this one, what does it executing means? It executing means a new node, next node, at this point it is pointing to null. Once it execute, it will point to head node. That means it will point to 702. Once you execute this line, execute this line. Now look at this next new node. So now if you look at this new node, you see 703 and his next node is 702 and their next node is 70. Look at this pattern: 703, 702, 701, 703, 702, 701. Okay, now new node is 703, right? But still this is not a head node, because if you look at your head node is 702, right? So that means your head node should point to this next node. So once you execute line number 35, so look at this, your head node. Now head node becomes 703 and the next node 702 and the next node 701, 703, 70 head node. And if you look at your next node, this is just next node is 703, 702, 701. Okay, now whatever the new node is there, 703, that you assign to head node. So at this point of time, your new node and head node both are same, but when you execute this line, your new node is gone. Your new node, okay, linked list. Yeah, you see head node. Your next node. Okay, next. Once you execute this one, then it will be gone. Anyway, so once you go here and print this one, so what it print? 30, 40, 50, null. Did you observe this guy? Okay, so we have, I just wanted to, generally what happened is I have seen a lot of other forum, they don't explain this thing right, and these are the basic concept. If you understand this one, then it will be in your mental model, and then you can think, okay, this is how it moves into the pointer. If you think how pointers move, how it is happening in your head, memory visualization, then it is easy to code. Believe me, coding is the last resort. It is not tough, but these visualizations should be clear. Okay, we have 10 minutes left, so I wanted to have any doubt or any questions, guys.
So, Bipin, one input is when you are telling about the insertions and deletions and all.
Yeah.
So we should consider the case of the existing linked list already being null, so that we directly make that head and report it back kind of thing. So
Right.
yeah,
Okay.
that will be one input, right?
Yeah.
It's
Correct.
very important use case in many conditions. The base case where most of the interviews do seek to find the base cases in your code that you have written.
Right, right. Yeah, I just explained at the basic. Yeah, but when you solve this problem, there are other see, once basic foundation is laid out, then everything can be built on top of that one. Yes.
Yes, correct.
Yeah. So I know there are a lot of people here. They are students, BCA guys. They are doing MCA guys, and they have some less experienced guys. But what I seen here is even 10 years, 9 years of experience. I was just literally taking interview and just say they are struggling. Means they don't know the concept. See, funda.
You are breaking up, Bipin again. I don't.
Okay, am I audible now? Is it fine now? Let me stop here. Okay, something went wrong.
It's better now.
It's better now?
Yes.
Okay, okay, perfect. Yeah, correct. So
Yeah, much better.
yeah. We need to lay the foundation. And yeah, so